students, welcome back to my lectures of class 10 physics. We are studying our chapter I and the colorful world. Okay, in the previous video we have seen that what actually dispersion is. That was the phenomena of splitting of white light into 7 colors. And now in this video we will see that what is the cause of dispersion. Okay, now to deal with the cause of dispersion, first of all we will see some relations. That is, first of all we will see relation between mu and v. This mu is refractive index and v is the velocity of light. First of all, what is the basic formula for refractive index? This mu is equals to c by v, where c is the speed of light in air or vacuum and v is the velocity of light in that medium whose refractive index is mu. Okay, now if I have two different mediums, then for the first medium I can write mu1 is equals to c1 by v1, and for another medium I can write mu2 is equals to c2 by v2. Okay, now I will take the ratio of these two refractive index. I can write mu1 by mu2 is equals to c1 by v1 whole upon c2 by v2. Okay, now here I can write this mu1 by mu2 is equals to c1 by v1 into v2 by c2. But here is c1 and c2, they both are same. Why? Because they both are the speed of light in air or vacuum and that velocity remains constant. So here I can cancel this c1 and c2. I can write here mu1 by mu2 is equals to v2 by v1. And you can see here this mu1 and here we have v1. Here mu2, v2. So from this I can write this mu is inversely proportional to velocity of light. Okay, मतलब यहाँ पर जितना ज़्यादा एक मटेरियल का रिफ्रैक्टिव इंडेक्स होगा उसके अंदर वेलोसिटी उतनी ही कम होगी. This is we have seen theoretically that the medium will be called as a denser medium, optically denser medium in which the speed of light will be less. And similarly, in case of the optically rare medium, the speed of light will be more. So here, that is the actual mathematical relation between the refractive index and the velocity of light. Okay, now here we will also find a relation between the refractive index and the wavelength of the light. Okay, now to find the relation between them, we will use this relation. I can write this mu1 by mu2 is equals to v2 by v1. Okay, now we have a relation between the velocity of light in air and the wavelength of light, and that relation is mu is equals to c by lambda. It also relates frequency. Okay, now this c is the speed of light in air. Now if I want to write the same formula for any medium, क्योंकि मीडियम के अंदर क्या होगा, जो स्पीड है लाइट की वो क्या हो जाएगी, चेंज हो जाएगी. So I can write this nu is equals to v by lambda. Okay, here one more thing, this is mu and this is nu. Okay, so that pronunciation is little bit confusing. Okay, now here we will see कि ये जो हमने रिलेशन लिखा है it is a generalized relation. अब यहीं पर ये रिलेशन अगर हमें दो मीडियम के लिए लिखना हो, then I can write this nu1 is equals to v1 by lambda 1 and nu2 is equals to v2 by lambda 2. Okay, now here I can write the relation of v1 and v2, that is v1 is equals to nu1 lambda 1 and v2 is equals to nu2 lambda 2. This v1 and v2 is the velocity of the light in the medium. Okay, now what I will do, I will put the value of v1 and v2 here in this equation. So I can write this mu1 by mu2 is equals to, at the place of v2 I can write nu2 lambda 2, at the place of v1 I can write nu1 lambda 1. Okay, we have seen the first law of refraction. What is the first law of refraction? That is, when light passes from one medium to another, then its wavelength and velocity changes, but phase and frequency does not change. Okay, so here this frequency nu2 and nu1, when the light is passing from one medium to another, its frequency does not changes. मतलब यहाँ पर क्या आ जाएगा? This nu1 is equals to nu2. Okay, so I can write here this mu1 by mu2 is equals to lambda 2 by lambda 1. As they both are equal, they will get cancelled out. Okay, so here you can see this is mu1 and here we have lambda 1. Here mu2 and it is lambda 2. Means here I can write this mu is inversely proportional to the wavelength of light. मतलब लाइट का वेवलेंथ जितना ज्यादा होगा उसके लिए जो रिफ्रैक्टिव इंडेक्स क्या हो जाएगा, कम हो जाएगा. So this is also an important relation by which we can see that what is the cause of dispersion. So the relation mu is equals to 1 by v and mu is equals to 1 by lambda, by these two relations we will see that why the dispersion takes place. So after looking at the relation between refractive index and velocity and refractive index and wavelength of light, we will see that what actually the cause of refraction is. Okay, here we have a prism. When a white light passes through it, it splits into 7 colors and we get a visible spectrum on the screen. Okay, now here we have seen the composition of white light. What is the composition of white light? It consists of all the different colors having different wavelength and frequencies. And we have seen that this each and every light, they have different wavelength and frequency. Okay, and this each and every color have different wavelength. This violet color, it have wavelength of 4000 angstrom, and for red color it have wavelength of 7900 angstrom. मतलब यहाँ पर कह सकते हैं कि जो रेड कलर है इसके लिए जो वेवलेंथ होती है वो कितनी होती है? मैक्सिमम, एंड फॉर दिस वायलेट कलर इट इज मिनिमम. Okay, now we have a relation between the refractive index and the wavelength of light. मतलब वेवलेंथ जितनी ज्यादा होगी उसके लिए जो रिफ्रैक्टिव इंडेक्स होगा मटेरियल का वो क्या होगा? उतना ही कम होगा. मतलब यहाँ पर अगर वेवलेंथ ज्यादा है तो हम यहाँ पर लिख सकते हैं that the refractive index will be minimum, and here if the wavelength is minimum I can write here the refractive index will be maximum. Okay, means for this particular color light, this glass prism, it will behave differently, and for the red color it will behave differently because of the wavelength of light. Okay, because this refractive index that depends upon the wavelength of light from this relation. Okay, now if we have the refractive index, then its velocity that will be also different, that is from this relation. अगर refractive index ज्यादा है तो उसके लिए जो speed light की उसके अंदर क्या हो जाएगी? कम हो जाएगी. Means here if mu is minimum, then the velocity will be maximum. So here I can write for this case the velocity will be maximum, and here in this case if refractive index is maximum, in that case this velocity will be minimum. So here for the red color light we are getting the maximum velocity, and for the violet color light we are getting the minimum velocity. Okay, now here we have a more important relation, that is if the velocity of any object is more, in that case its deviation will be less. Okay, and similarly if the velocity is less, in that case the deviation will be more. So here this velocity is maximum, in that case the deviation I am representing it with del, so this del will be minimum. And here in this case if the velocity is minimum, in that case you can write this del will be maximum. Okay, here this you can see that whenever you are throwing any object with greater speed, in that case it will move straight, मतलब वहाँ पर deviation नहीं होता है. On the other side if you will move any object with a slower speed, in that case it will deviate more. तो वहां से आप निकाल सकते हो दोनों के बीच में relation, the relation between the velocity and the deviation. Here if the velocity is more, then deviation will be less. Here if the velocity is less, then deviation will be more, and you can see this deviation here. यहाँ पर जो हमारे पास रेड कलर है इसके लिए डेविएशन सबसे कम है, इसीलिए क्या है? सबसे ऊपर की तरफ है. और यहाँ पर जो वॉयलेट कलर है इसके लिए क्या है? डेविएशन मैक्सिमम है, इसीलिए ये सबसे नीचे यहाँ पर डेविएशन बहुत ज्यादा हो जाता है. इसको आप ऐसे भी देख सकते हो कि हमने एंगल ऑफ डेविएशन की डेफिनेशन क्या देखी थी? इट वाज द एंगल बिटवीन दी एक्सटेंडेड इंसिडेंट रे एंड दी इमर्जेंट रे. इसको हम पीछे की तरफ यहाँ पर कर देंगे. दिस एंगल इज वॉज द एंगल ऑफ डेविएशन. तो यहाँ पर जो वॉयलेट कलर है इसके लिए एंगल ऑफ डेविएशन अलग है, और यहाँ रेड कलर को जब पीछे की तरफ एक्सटेंड करेंगे, इन दैट केस वी विल गेट दिस एंगल, एंड दिस इज डेल्टा फॉर रेड एंड दिस इज फॉर वॉयलेट. Okay, and you can see this red color, its value is less as compared to the violet color. So this is what the reason why we have the splitting of white light into 7 colors. That is actually because of the wavelength of the light. कि अगर लाइट की wavelength different होगी तो उसकी वजह से वहां पर जो refractive index होगा, जो मटेरियल उस लाइट के लिए ऑफर करेगा, that refractive index will be different. और अगर refractive index different होगा for different color lights, then the velocity will be also different. और जब velocity different होगी, in that case the deviation will be also different, और उसकी वजह से जो white light है वो 7 colors में split हो जाती है. Okay, and this is all about the dispersion of white.